Let's practice finding the slope given 2 points. For number 1, we have this point -4, 2, which we're going to go ahead and call x1 and y1. Then we have this 4, 0, which I'm going to call this x2, y2. Okay? Now to calculate slope, remember what we're going to do here is we're going to say slope, or m, is equal to rise over run, but rise is really just a difference of the y values, because that's a vertical change, and we can find that from doing y2 minus y1. And now you can also do y1 minus y2 if you would like to. It's really a preference, as long as you're consistent on top and bottom. Now for dealing with the x's, if we went from y2 minus y1, just also do x2 minus this x1. So if you go 2 to 1, go to 2 to 1. If we go from 1 to 2, use 1 to 2. Now to solve for the slope, all we're going to have to do is substitute these values in. So if we go ahead and say y2 is going to be 0, we're going to take 0 and then subtract this y1, which is going to be this 2, and then we're going to put that on top of x2 minus x1. Now x2 is equal to 4, and then it looks like this x1 is going to be this -4, so we're going to take away -4. On the top here, 0 minus 2 is going to equal this -2, and in the denominator here, 4 minus -4, that's going to equal +8. So this -2 over +8 is going to result into saying the slope is going to be -1/4. So that's the slope for number 1. And if you want to visualize this -4, +2 would be somewhere over here in quadrant 2, and this 4, 0 would be somewhere over on the positive x-axis, right over here. And if you connected these two dots, you would get a negative slope because it would be going down to the right. Here's number 2. For number 2, we have 6, -2 and 3, -8. And just like the previous example, we can label our x1, y1 and x2, y2 and get started right away into substituting in. So substituting some values in here, we're going to take this y2, which is -8, and then we're going to subtract this y1, which happens to be -2. So we have -8 minus -2 in the numerator, and in the denominator, it looks like we have x2, which is going to be +3, and we're going to take away this x1, which is going to be +6. All right. In the numerator, we have -8 take away -2, which is -8 plus 2. We can go ahead and just call that -6, and in the denominator, 3 minus 6, that's going to equal -3. All right, so if we have a negative divided by a negative, that's going to be a positive. So our slope here is going to be +2. That would be our slope for this linear equation going through these 2 points. And if you want to see what this visually looks like, 6, -2 would be somewhere in quadrant 4, maybe something like that. And then this 3, -8 would be over in quadrant 4 as well, but it would be somewhere down here. So if you were to connect these 2 dots, you do get a positive slope, so that makes sense. For number 3, let's take a look at -5, -1 and -1, +1. So I just went ahead and labeled our x1, y1 and x2, y2, and let's go ahead and start substituting in. So for y2, it looks like we have +1. We're going to take away y1, which happens to be a -1, so I'm going to put that in parentheses. Keep track of all of our signs here. And then for x2 is -1, and we're going to take away x1, and that looks like it is -5. So we have this -1 take away a -5. Now in the numerator, we have 1 take away -1, which is just 1 plus 1, and that should equal 2. And in the denominator, we have -1 take away -5, which is just -1 plus 5, and that's going to equal +4. 2 over 4, that's just going to simplify to 1/2. So we can say this is going to be 1 over 2. That's the ratio, or the slope. And so we know m, or the slope for this linear equation, is going to be +1/2. And visually looking at this -5, -1 would be over in quadrant 3, maybe somewhere like over here. And this -1, +1 would be in quadrant 2, maybe something like here. And so you can see that it has definitely more run than rise, which makes sense because there's only a rise of 1 and a run of 2 for the ratio. For number 4, we have this -9, 4 and -3, -4. Once we have them labeled, let's go ahead and start substituting in. So y2 for me here is going to be -4, take away, and then y1 is going to be a +4. And so let's do -4 minus +4 on top, and then in the bottom we have x2, which is going to be -3, and let's go ahead and take away our x1 value, which is going to be -9. So let's go ahead and put -9 right in the bottom. Now if we go ahead and say -4 take away 4, that's the same thing as -4 plus -4. That's going to be -8 on top. And in the bottom here we have -3 take away -9, which is just -3 plus 9. that's going to equal positive 6. And so if we divide both of these by 2, we're going to end up with the ratio of negative 4 to 3, and that is what the slope is here, negative 4/3. Now, if you visually want to take a look at this, our x1, y1 is going to be over in quadrant 2, this negative 9 comma positive 4, maybe something like that. And then for the negative 3 comma negative 4, that would be somewhere in quadrant 3, maybe something like this. So if you connected those two dots, you would see a downward sloping line or a negative slope, which makes sense because we got a negative 4/3 for the slope. Here's number 5. For number 5, we have negative 9 comma 6 and 5 comma negative 6. Substituting our values in here, our y2 is going to be this negative 6. So take negative 6 and take away this y1, which is going to be positive 6. And let's put that on top of x2 minus x1. x2 looks like it's positive 5. We have positive 5, take away x1, which is going to be negative 9. So let's put that in parentheses. All right, on top here, negative 6 take away 6 is the same thing as negative 6 plus negative 6, or negative 12. And in the bottom here, we have 5 take away 9, which is really 5 plus 9, and that's going to equal 14. Now, since we can divide both of these numbers by 2, let's go ahead and do that to simplify. So this would be negative 6 over 7 for the slope. All right, so m equals negative 6 over 7, so we have a negative slope for the linear equation that goes through these 2 points. Now, if you want to just visually make sure this makes sense, this negative 9 comma positive 6 would be somewhere in quadrant 2, maybe something like this. And then if we went and plotted our other point of 5 comma negative 6, that would be somewhere in quadrant 4, maybe something like this. So if you connected these 2 dots, we definitely would have a negative slope. Here's number 6. We have 0 comma 6 and 5 comma negative 4. Let's go ahead and just label them right off the bat and then start substituting in. So y2 here is going to be negative 4. So let's take negative 4 and then subtract y1, which is this positive 6. And let's put that on top of the difference of the x value. So for x2, looks like we have 5. And then for x1, let's go ahead and subtract x1, looks like it is 0. Now in the numerator, this negative 4 take away 6 is the same thing as negative 4 plus negative 6. That'll equal negative 10. And in the denominator, 5 minus 0 is going to be 5. So it looks like we have a 2-to-1 ratio here, but 10 divided by 5 is negative 2. So let's make this negative 2 for our final slope. And so we say m equals negative 2. So we have a pretty negative slope here. Let's see if this visually makes sense. And visually, just to check this, 0 comma 6 would be along the y-axis, maybe something like right there. And then our 5 comma negative 4 would be in quadrant 4, maybe something like over here. And if you connected those, you would definitely have a pretty steep negative slope. For number 7, we have 9 comma 5 and negative 6 comma negative 1. There's our x1, y1, and x2, y2. And if we go ahead and start substituting in, for y2, let's have negative 1, and let's take away y1, which is going to be this positive 5. And let's put that over the difference of the x value. So for x2, we have negative 6. So we'll take negative 6 and take away x1, and I think x1 is positive 9. So on top here, negative 1 take away 5. It's the same thing as negative 1 plus negative 5. That's going to equal negative 6. And in the denominator, negative 6 take away 9 is the same thing as negative 6 plus negative 9, and that's going to equal negative 15. So we do have a negative over negative, which becomes a positive, and we can divide both by 3. And if we do that, we're going to get 2 over, let's see, 5. All right, so that's going to be the slope here. And to check this visually, 9 comma 5 is going to be in quadrant 1, maybe something like over here. And this negative 6 comma negative 1 is going to be somewhere in quadrant 3, like here. And so if you connect those, you'll get a positive slope, but there's definitely more run than rise, so it's not too steep because 5 is bigger than 2. For number 8, it looks like we have 7 comma negative 1 and negative 1 comma positive 1. Once we have them labeled, we can just go ahead and start substituting in. So y2 looks like it's 1, and we're going to take away y1. That's going to be negative 1, so let's substitute that in, put parentheses just to keep things organized. And then for x2, we have negative 1, so I'm going to take negative 1, and let's take away this x1, which is positive 7. All right. In the numerator, we have 1 take away negative 1, which is really just 1 plus 1, and that's going to equal 2. And in the denominator here, negative 1 take away 7 is really negative 1 plus negative 7, which is negative 8. And then we can divide these both by 2 and move the negative to the middle. And this will be negative 1/4 for the most simplified slope. So m equals negative 1/4. All right, so that would be the slope here. Visually, just checking this, 7 comma negative 1 would be somewhere in quadrant 4, like here. And then for the negative 1 comma positive 1, that would be in quadrant 2, somewhere like right here. And if you go ahead and connect those, we do have a gradual negative slope. Here's number 9. For this one, we have 8 comma 2 and negative 1 comma negative 7. Go ahead and label them, and let's start substituting in. So for y2, we have negative 7. So let's do negative 7 take away y1, which is 2. And let's put that over the difference of the x's. So for x2, we have negative 1 take away 8. In the numerator, negative 7 take away 2 is really negative 7 plus negative 2, which is negative 9. And in the denominator, negative 1 take away 8 is same thing as negative 1 plus negative 8, which is also negative 9. So it's a 1-to-1 ratio, so this is just going to be positive 1. So we know the slope of the linear equation going through these 2 points is just going to be positive 1. Visually, 8 comma 2 would be somewhere in quadrant 1, maybe like something like here. And then for the second point of negative 1 comma negative 7 would be somewhere down in quadrant 3, closer to the y-axis, maybe something like here. And if you take a look at connecting those points, you would get a pretty diagonal line that is a 1-to-1 ratio of up 1 over 1. For number 10, we have negative 5 comma negative 18 and 9 comma positive 3. Go ahead and label each of our points so we know where to plug things in. y2 is going to be 3, and we're going to take away y1, which looks like it is negative 18. That's going to be our numerator, and for the denominator, x2 is 9. And let's take away x1, which is negative 5. In the numerator, 3 take away negative 18 is just 3 plus 18, and that's going to be positive 21. And in the denominator, 9 take away negative 5 is 9 plus 5, and that's going to be 14. The GCF here is going to be 7, so we can divide them both by 7. If we do so, we're going to get 3 over 2, and that's going to be the slope of the line that goes through these 2 points. Visually, hopefully this will make sense because negative 5 comma negative 18 would be maybe somewhere down here in quadrant 3, and then this positive 9 comma positive 3 would be somewhere over here in quadrant 1, and it should be a little bit more vertical than horizontal, but not by much because 3 and 2 are pretty close to each other. For number 11, we have negative 2 comma 0 and 7 comma negative 12. Go ahead and label them for our x1, y1 and x2, y2 and start substituting in. y2 is negative 12, and let's take away y1. Looks like it's 0. And let's put that on top of x2, which is 7, minus x1, which is negative 2. On top, negative 12 minus 0 is going to be negative 12. And in the denominator, 7 minus negative 2, or 7 plus 2, will be positive 9. Let's go ahead and divide these both by 3 and put the negative in the middle. We'll get negative 4/3 for the slope. That's the ratio of the rise to the run for this linear equation. So it should be a little bit more vertical change to horizontal change. Let's see what this looks like on a graph. Negative 2 comma 0 maybe would be something like here along the negative x-axis, and then 7 comma negative 12 would be over in quadrant 4, and it should be pretty down here in quadrant 4. So you can see it's a little bit more downward movement as opposed to the right movement from the purple to the reddish dot. Okay, moving on to number 12, we have 7 comma negative 2 and 3 comma positive 10. Substituting in, we have y2. y2 is 10 minus this negative 2. And in the denominator, we have x2, which is 3. Let's take away x1, which is 7. On top, 10 take away negative 2 is just 10 plus 2, or 12. And on bottom, 3 minus 7 is going to be negative 4. 12 divided by 4, that's going to equal 3. So this is just going to equal negative 3 for the slope. So we can say m equals negative 3. This should be a pretty steep negative slope here. So if we plot this on a graph, 7 comma negative 2 would be maybe here in quadrant 4. And then this 3 comma 10 would be maybe up here in quadrant 1. And so it's a pretty steep downward movement if you go from this 3, 10 to the 7, -2. For 13, let's see, we have -4, 2 and -10, 2. Now that we have these labeled, let's go ahead and substitute in. So for y2, we have 2, and let's take away y1, which is also going to be 2. So something interesting may be happening here. We have some matching values. And then for x2, we have -10. So let's have -10 take away our x1, which looks like -4. Now in the numerator, 2 minus 2 is going to be 0. And in the denominator, -10 take away -4 is just -10 plus 4, and that's going to be -6. Now 0 divided by anything is just going to be 0. So we're going to have a slope of 0 here. We actually are going to have a horizontal line. Now, if you visually want to see this, you can also confirm in the future that whenever the y values match, so y1 and y2 are both the same value, then these two dots will literally be next to each other. So -4, 2 is here, and then maybe -10, 2 would be over here. And so if you connected them, it would just be a horizontal line. Here's number 14. For 14, we have -15, 2 and 5, -13. Here they are labeled, and substituting in here, y2 would be -13. And let's take away y1, that will be +2. That's going to be the numerators. And for the denominators, for x2, we'll have 5. And let's take away x1, which is -15. In the numerator, -13 take away 2 will be -15. And in the denominator here, 5 take away -15 is just 5 plus 15, and that's going to be 20. The GCF here is going to be 5, so divide both of these by 5, and we will get -3/4. And so that is going to be the slope for the linear equation that goes through these 2 points that we were given. All right, now visually, let's just check this out here. -15, +2 would be maybe in quadrant 2 over here. And then for the 5, -13, that would be in quadrant 4, maybe somewhere down here. So it would have a negative slope. For 15, we have 7, -4 and 7, +9. They have matching x values this time. Here they are labeled up, and so let's go and see what happens, but this one's also going to be kind of interesting. So on top, we're going to have 9 minus -4. All right, that's y2 minus y1. And in the denominator, we're going to have x2 minus x1, and I believe that's going to be 7 take away 7. Now in the numerator, 9 take away -4 is really just 9 plus 4, and that's 13. And that actually doesn't really matter, because see what happens in the bottom, 7 minus 7 is 0. And so you can't have 0 in the denominator, can't divide by 0, so we call this undefined. All right, and this always will happen if you have 2 points that have matching x values, right? And you'll see visually what's going to happen here. So we can't divide by 0, right? And so if you look at these visually, 7, -4 is going to be over in quadrant 4, maybe like here. And then 7, +9 is over 7 also, but up 9. Right? So these dots are right on top of each other. So there's definitely rise, but there's no run. And so whenever you have 2 dots on top of each other, their slope is undefined. Last one here, number 16, we have 17, -13 and -13, 11. This is our x1, y1 and x2, y2. For y2, let's plug in 11. And for y1, let's plug in -13. That'll be the numerator. And for the denominator, for the run, x2 will be -13. -13 take away, what is x1? Looks like that's 17. On top, 11 take away -13 should be 11 plus 13, or +24. And in the denominator, -13 take away 17 should be -13 plus -17, also known as -30. Now you can divide both of these by 6, or their GCF. And if you divide both by 6 and move the negative into the middle, then you're going to get, let's see, 4 over 5. So our slope here is going to be -4/5. So our slope here is -4/5, so it should be pretty close to a 1-to-1 ratio, or that diagonal line moving down to the right. So 17, -13 would be maybe somewhere like here. And then this -13, 11 should be somewhere over in quadrant 2 like this. So we definitely have a negative slope. All right, so there you have 16 different practice problems on finding slope given 2 different points. If you found this video helpful, please consider giving it a thumbs up. And as always, keep up the great work, and I'll see you in the next one.